Hello everyone. So the next question of matrix we have is let A is equal to 1 0 0 0 4 minus 1 0 12 minus 3. The sum of the diagonal element of the matrix A plus I to the power 11 is equal to, right? We have been given one matrix of 3 cross 3, that is matrix A, right? And we have to find the sum of the diagonal element of this thing, right? A plus I to the power 11, and we have been given 4 options. The 4 options are 6144, 4094, 4097 and 2050, right? Let's see how we can proceed to this question. First of all, what we can do, we have to find the value of A square, and we can find the value of A square just by multiplying matrix A with matrix A, right? Matrix A multiplication with matrix A will give the value of A square, right? So I am multiplying matrix A with matrix A, and I writing the next A 0, 12 and minus 3. Let's see what we get, and I believe everybody knows that how matrix multiplication can be done. For those who don't know, the first row will get multiplied with the first column, the first row again get multiplied with the second column, first row again with the third column, right? Likewise, the second row will get multiplied with first column, second row with second column, second row with third column, third row with first column, third row with second column, and third row with third column, right? So I am multiplying this number, right? So first I will get 1 into 0, and this will equal to nothing but 1. First row, second column, I will get 1 0 0, and it will be 0. First row, third column, this will become 0 0 and 0. So first row I got. Now second row, first column, 0 into 1 is 0, 4 into 0 is 0. So again here it will be 0, right? Now second row, second column is 0, 4 4s are 16, 16 minus 12 is 4, right? Second row, third column is 0, 4 minus 4 and plus 3 is minus 1, right? Third row, first column is 0, 0 and 0. So here it will be 0, right? Third row, second column will be 0, 12 4s are 48, 12 3s are 36. So it will give 12, right? Third row, third column, 0, 12 minus 12 and plus 9. Minus 12 and plus 9, what will be? It will give minus 12 and plus 9 is minus 3, right? Now this is the value of A square, right? Let's observe something. If we observe that what we got as A square, it is just similar to A only, right? Although we have multiplied matrix A with matrix A, but again we are getting the same thing, right? So it means that no matter how many times we will multiply the matrix, right, the result always will be same. So I can write the observation as A is equal to A square, A cube, A to the power 4 and so on, right? It will continue, right? Any power of A is equal to A only, right? Now we have to find the value of A plus I to the power 11. A plus I to the power 11, and the expansion can be written as from 11C0 A to the power 11 plus 11C1 A to the power 10 and so on up to 11C10, and here I can write A plus 1, and here I can write 11C11, and here I can write I, right? So this will be the expansion of this term, right? A plus I to the power 11, I can expand this as 11C0 up to 11C11 and in this manner, right? Now what we can observe in the first, from here to here, there is one term that is common, and the common term is what? A, right? So what we can do, I can write 11C0 plus 11C1 up to what? 11C10, and I can take A as common because A to the power 11 will be equal to A to the power 10 and so on, right? Any power of A, the value of A, it will be equal to A only, right? So I am taking A as common, and the last term I am writing it as 11C11I. Right? Now for these terms from 11C0 to 11C10, what I can write it as 2n minus 1. 2 to the power n minus 1, and here n will be equal to what? N will be equal to 11 only, right? And here I am taking a plus 11c 11, 11c 11 is nothing but, right? So I can write it as 11c, right? This will be the final simplification. Now we have to find only the sum of the diagonal element. So let's see what is the sum of the diagonal element of a. Diagonal element is 1 plus 4 5, 5 minus 3 is what? 2 only, right? And 2 to the power 11 minus 1, and sum of the diagonal element of a is 415 minus, it will become 2, right? And plus 3. So 2 to the power 11 is how much? 2 to the power 11 is 20 and 48. 2048 will be the value of 2 to the power 11. 2048 I am writing here. 2048 minus 1 into 2 plus 3. 2048 minus 1 will be 2047, and 2047 into 2, that is nothing but 4094. 4094 plus 3, this will be equal to how much? 4097. This will be equal to 4097. So the final answer which I am getting is 4097. Let's see, is there any option 4097? Yes, option C is given 4097, and this is the correct option, right? So the correct option of this question will be 4097.